Hello, everyone. This is the beginning of Chapter 6, our new chapter on linear relations. And our first section here is on slope. You've probably heard of slope before. And so we're going to start by actually listing a few other words for slope that you might have heard of. So another word for slope is pitch. Sometimes you hear about the pitch of something. The slant, which is probably the more common word for slope, or the steepness. So depending on how steep something is, that means that its slope has changed. So what are some real life examples of slope? Well, as you can see, I've got a picture of a mountain there, and that's a bit of a hint because mountains have some steep slopes on them. So anything that you might do on a mountain, like hiking, climbing, skiing, anything with uphills and downhills like that, roofs and roofing. If you do roofing and building, that's one of the ways you might have heard of that term pitch, the pitch of a roof. We have, if you've taken driver's ed, you know that there are some road grade signs that say a certain percentage of grade or elevation or decline on a road. A simple example of that is a driveway. Driveways are usually sloped. And then even some activities like somebody has adjusted zip lines. Some common ones that you'll see in different buildings are escalators, staircases, things like that. So there's many real life examples of slope, and those are just a few of them to get you thinking about this concept of slope and how it really is all around us. So we have 4 different categories that we will say slopes are categorized into. So the first is a positive slope, which is as you go to the right, you're going up. In other words, it's like an uphill climb. A negative slope is like a downhill as you go to the right. Horizontal means you have a slope of 0, like on a lot of the prairies has a slope of 0. And an undefined slope is if you have a vertical slope like this. Okay, so what we're going to do in this next activity here is classify some different types of slopes. And so I'm going to start with the letter M, and each line that makes up the letter M has some kind of slope. So my first one here, this first stem of the M, is actually undefined because it is vertical. So that's undefined. This next one is downhill, so that's negative. This next one is uphill, so that's positive. And then this last one going straight down again is undefined. We look at the letter A. It starts off with a positive slope. Then we have a negative slope to make the other half of the A. Then the crossbar here is actually a 0 slope. We look at the T. We start off with usually drawing the top first. That's the 0 slope. And then we could say that the stem of the T here is undefined. Looking at the H, we have all vertical and horizontal pieces. So we have 2 undefines, and the cross is a slope of 0. So just a little bit of fun with some letters there. Now to actually calculate the slope mathematically, we have a formula. And we've seen this formula before. We just wrote it a little bit differently. But our formula for slope is rise over run. And this is a very major concept in mathematics and science classes. You may have also even seen this in your various science classes. So I'm really going to highlight that. Now, one way that you can shorten that formula a little bit is to write an M instead of writing out the word slope. So if you see me use an M, that means the same thing as slope. And I'm just going to make a note here that when we were in chapter 5, we used this same formula, but we described it differently. So in chapter 5, in the last set of lessons that you watched last week, we called this the rate of change. And we said that the formula for that was rate equals the change in dependent variable over the change in independent variable, which in other words, was the change in our y values over the change in our x values. So just making a note of that, and we will see this concept come back in future examples. So just here saying that the letter M can also be used to indicate slope, and a couple more blanks to fill out here. Rise refers to the vertical change, and run refers to the horizontal change. And I'll explain what that means in the next few examples here. So here's a pretty typical slope example. It's asking you to determine the slope of a line segment based off of its graph. Okay, so here we have point A and point B, and I'm going to draw a few helper lines on here to show my rise and my run. So I can add a rise line and a run line. Basically, I'm creating a right triangle out of this slope. Okay, so my rise is what I would get from counting these squares. So that's 1, 2, 3, 4, 5, 6. So the rise was 6, and the run was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go ahead and calculate my slope. So I know that my slope is rise over run. And the rise was 6 and the run was 10. And I'm always going to reduce my answers when possible. So the slope of that line we would say is 3/5. That also means that every time I go up 3, I'm going over 5. And so there's another point. Up 3, over 5. Let's take a look at B. Now B, we notice right away it's going the other direction. It's going to have a negative slope, and I'll show you what that looks like in terms of a calculation. So the slope on B is rise over run. And we're again going to draw a few helper lines here. This time our rise is going downwards. So that's where we're going to get our negative. It's going to be a negative rise, but always a positive run. So this time we went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to go across a run of 1, 2, 3, 4, 5. So our rise is -10 and our run is 5. So the run is always going to be positive. So the rise is -10, the run is 5. And again, I always reduce that. That becomes -2 over 1, which we just write as a final answer of -2. So if you see a slope of -2, you know that means it's going down 2 and over 1, even though we don't write the fraction over 1. Okay, I like this example. It's kind of a neat one here where we're going to just draw a bunch of line segments, each with a given slope, and then we'll label them A, B, C, D, etc. So I'm going to choose a place to start. I'm going to connect them all just for fun. And I'm going to choose to start here. Okay, so from here, I'm going to count up 7 and over 5. Remember, this is rise and this is the run. So up 7, 1, 2, 3, 4, 5, 6, 7, and then over 5, 1, 2, 3, 4, 5. So that's where I end up when I go up 7 and over 5. I'm going to go ahead and draw that line segment. And I'm going to label that A. Now I'm just going to make it like a connect the dots. Just why not? So now I'm going to go for my next one. We'll have -2 over 3. So I consider the negative to be part of my numerator here. So I'm going to go down 2, but over 3. So there's my next point. And I'm going to go ahead and draw that line segment, and that is segment B. C is up 1 and over 2. So a slope of up 1 and over 2 would put me here. And there's my line segment to join. And that is going to get labeled C. D is down 1 and over 4. So there's D. So down 1 and, down 1 and over 4 puts me there. E, a slope of 1. Now, some people get confused when they just see a single number there, But remember, 1 can be written as 1 over 1. That means I'm going to rise 1 here, and I'm going to run 1 also. So my rise and my run are equal. That means I'm going to go up 1 and over 1. And you know what? I can do this as many times as I want. There's nothing saying that I can only go 1 set of slope. I'm going to go 4 this time, just for some variety. Okay, so that is line segment E. F has a slope of -4. Once again, that means -4 over 1. So that means I'm going to drop 4 and go over 1. And what the heck, I'm going to do that twice here. So there is segment F. Segment G is a slope of 0. Remember from our previous examples, a slope of 0 is just a horizontal line. So I can draw that going on as long as I want here. So there is segment G. And then H is undefined, which of course means a vertical line. So I'm going to go H. It didn't say how long to make my line segments, so I had a bit of fun there at the end and made some of them a bit longer just for interest's sake. So there are my different segments. Example 3 and then example 4 will be our last one. So this is our last page for this section. So example 3 is asking us to determine the slope of a line that passes through point C, which is at -5, -3, and point D, which is at 2, 1. So I'm going to start by plotting those points. So remember, the first number listed in an ordered pair is always the x-coordinate, and the second number is the y-coordinate. And so this is our x-axis, and this is our y-axis. So we always start at the origin, which is 0, 0. But for point C, I have to go to -5 on x, so 5 to the left. And then I have to go 3 down. So that is point C, which is at -5, -3. D, I go back to the origin, and I go 2 to the right and 1 up. So that is point D. I think it makes sense here to draw this line segment because it's asking us to find the slope. So the way that I would do that is, and I find this the most handy, I'm going to switch colors here, is just to show my rise and my run. There's the run, there's the rise. I could have also drawn it on this side, rise and run. So it doesn't matter which way you want to draw your triangle. Anything's fine. I'm going to do it this way because that's what I drew first. I'm going to go ahead and calculate those. So the rise is 1, 2, 3, 4. I went up 4. The run was 7. 7 across. 1, 2, 3, 4, 5, 6, 7. So my slope, I'm going to use M this time just because I haven't done that yet. My M, or my slope, is rise over run, which is 4 over 7. That can't be reduced, so that is my final answer. Now, they're going to ask us to do the same thing, but without sketching the line. So it makes it a little bit more difficult, but we have a bit of a trick up our sleeves to help us. So I'm going to say that this is my first point, and I'm going to label its coordinates x1 and y1. This is my second point. I'm going to label its coordinates x2 and y2. The reason I have to put 1s and 2s on here is just to show that F is my second point and E is my first point. And it doesn't matter which one you call your first point and which one you call your second point. Okay, so slope, or the M value, is going to be rise over run. Now remember from our previous unit, we know that that means the change in our y values over the change in the x values, or the difference in each. So I'm going to say that this is y2 minus y1 and x2 minus x1. And therefore, I can go ahead and plug in my numbers. So y2 is 6. So I have 6 minus y1, which was -5. And then I have 8 minus 4. Just going to scroll up so we can see this a little bit better. 6 minus -5 is 11. 8 minus 4 is 4. 11 over 4 can't be reduced, so that's our final answer. We could have done that over here on this one, but it was easy because it was drawn out to just count it. So here's what you can do if you don't have a drawing, is you can use this formula. So this is another way of calculating slope that a lot of people find handy if you know 2 points. All right, example 4, our last example for this section. Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. He plotted these points on a grid. What is the slope of the line that passes through these points? Okay, so it looks like if I were to draw the line for Tom's pay, it's going through all of those points, and we want to figure out what the slope is. So we're going to do some rise over run work. And I can pick any 2 dots to look at. So I'm going to pick this one to find the rise and this one to find the run. So it's a little bit hard for me to draw straight on here. Sorry, here's my triangle on this one. So the rise is 2 squares, but each square here is not worth 1. Each square is worth 12. So I actually went up 24 as my rise, and my run is 1 for 1. 1, 2, 3, 4. So my run is 2. So you have to be careful. It looked like the slope was going to be 2 over 2 if you didn't look at the actual numbers and units over here. So the rise was actually $24, and the run was 2 hours. Don't forget about the units. When we reduce that, that actually becomes simplified to be $12 an hour. So if somebody says they're working at a job and it's $12 an hour, what are they talking about? They're talking about their rate of pay or their hourly wage. So Tom's hourly wage is what is represented by the slope. Actually, I'm going to write a whole sentence there. Slope represents Tom's hourly wage. And I'm just going to add in brackets that that is the same thing as his rate of pay. So slope usually means rate, and it usually has a per in it because it is a fraction. Part C, using your answer from part B, determine how much Tom would earn in 3.5 hours. All right, so if he works 3.5 hours and gets paid $12 an hour, let's figure that out. So he gets paid $12 an hour, and you would multiply that by 3.5 hours. The hours would cancel out because I've got 1 in the numerator, 1 in the denominator. That will give me a final answer in dollars, and that ends up being $42 exactly. So after 3.5 hours, he would earn $42. Using your answer from part B, determine the time it took Tom to earn $30. So what if we did that backwards? We're going to set up the same equation. So $12 an hour, and I'm just going to call this T for the time it took him. And that will now equal $30. So first of all, I know my answer is going to be less than 3.5 because he made $42 in 3.5 hours. So let's see what this ends up being. To solve for T, I'm going to divide each side by $12 per hour. The dollars cancel. A per hour moves it back up. It's basically on your calculator, 30 divided by 12, and I get an answer of 2.5 hours, which seems reasonable because I knew it had to be less than 3.5 hours. The other thing that makes it reasonable is it's not a negative answer. If I got an answer like he worked -5 hours, well, that should tell you that maybe there's a mistake. Okay, that takes us to the end of this section on slope. So thanks for watching this video. The next unit, or pardon me, the next lesson will be on slopes of parallel and perpendicular lines. So stay tuned for that one. That one is coming up next. Thanks for tuning in.